There we go. All right, so let's talk linear equations this evening. So again, this is one you've probably been with us before. So let's go ahead and get started. So we know this is the main thing coming out of the heart of algebra subsection, at least of the SAT. It's usually within its own section on the ACT, just called algebra. But they functionally are very, very similar. The SAT is going to have you know a few more things relating to algebra, but our emphasis today is one specific one, linear equations. And let's start with those. So linear equations, the base word of linear, right, is line, right? And a line on a graph is just going to be exactly what it sounds like, a straight line, which may sound self-explanatory, but the definition of a line is that it must have a constant slope, which means it's gonna, it can't look like, this, it can't look like this, it can't look, like that. Nope, it's got to move exactly the same. So all those are not going to be lines, right? It's got to be on a graph. It's got to be a straight line like that. That's what we're going for. All right. Now, when we talk with linear equations, there's a special form that we see them in most times, and that is called slope-intercept form. There's not a lot of times that knowing the name of something is super important for this course or for the SAT, ACT, but this is one of those exceptions because slope-intercept form tells us exactly what this form gives us, and that is the slope of a line and the y-intercept. So there it is. It's written in the form y equals mx plus b, where we've got a few different things. We've got x, y, which are points on the line. We have m, which is the slope, which if you remember this from class is represented as that rise over run, and we'll talk about that more in a minute. So x, y are points on the line, m is the slope, and then we have b, that number out there all alone, that is the y-intercept, or where the line crosses the vertical or the y-axis. And if you don't remember quite what I'm talking about as far as the vertical axis, I'm referring to the up and down of the graph, right? That's the y-axis, while the left and right, the horizontal would be the x-axis. So wherever that line touches that vertical up and down one, that is where but that's what that b value is going to be, okay? All right, so that's what each thing represents. So again, three key things: the slope, the x, y, the points, and then that b value, which is the y-intercept, but mostly the slope and y-intercept, right? So that's each component of y equals mx plus b. Now we can have a little bit more in-depth conversation about slope. So slope, we called it rise over run, and what we meant by rise over run was a fraction in which the numerator or the top was y, whatever and I'm going to use we'll actually just use the word change in y over the change in x. So basically, how is our graph moving up and down vertically? That's the change in y on top, over how is our graph moving horizontally? The change in x, which is the bottom of that fraction, okay? Sometimes you'll see represented by the Greek symbol delta, which is the triangle, change in y over change in x. All right. Now we do have a formula for this, and it's a very, very important formula. And if you ever see a collection of those formulas, you must know for the SAT and ACT, especially the SAT, it's to know the slope formula. So if we want to calculate m, or the slope, this is the formula: y2 minus y1 over x2 minus x1. Given, this is when we are given 2 points. So that's what we need. If you're taking notes, that's a great thing to write. If we want to calculate slope, we need 2 points, because then we can use that formula, because those 2 points are x1, y1, and x2, y2, which really just represents the x and y values of 0.1 and 0.2. So when we subtract them, and the great part is it doesn't matter which is which, doesn't matter which one is which, matter which point is 1 or 2. So to give you an example of that, of using this formula, this very, very important formula, let's say you were given the points 2, 5, and 4, 10. So if we wanted to calculate the slope, we would go m is equal to, on top, let's say this was, let's just randomly choose, this is going to be 0.1, this is going to be 0.2. Y2 comes first, right? The y value of the second point, that's 10. So 10 minus the y value of the first point, that's that 5, over x2, the x value of the second point, which was 4, minus the x value of the first point, which was 2. When we simplify that, that comes out to 10 minus 5 is 5, over 4 minus 2 is 2. And that slope would be 5 halves, or 5 over 2. There we go. So that's how we calculate slope, okay? So I will go ahead and save that to my photos and put it in the chat before we leave. So there we go. That's how we calculate slope. And keep in mind now, right, we can get those points. So if we do slope continued, we can get those 2 points from a lot of different ways. 2 points can come from a table, right? Like x, it could be like, oh, x, y, like this, x, y, and then it could be like, 1, 2, 2, 4, and you go, okay, first point is 1, 2, because when x was 1, y was 2. Second point was 2, 4, because when x was 2, y was 4. So it can come from a table. It can come from a graph, right? You could have a graph and be like, oh, look, it had the point 1, 2 right there and the point 2, 4 there. And then you can calculate the slope that way. Or we can just be given 2 points, given the coordinates, right? Like x, y, x, y. So there's a few ways we basically get those from, okay? And we're going to see all of these in action pretty soon. All right, so that's slope. Before we go any further, we want to make sure we can isolate a variable and make sure we know that term. So to isolate a variable is to solve, it means the same thing as to solve for a variable, and all it means is get it alone. Okay. And these kind of problems manifest themselves in a couple different ways on the SAT and ACT. So sometimes we'll see ones that are pretty simple, honestly, and they're just, okay, let's say z minus 5 or 2z minus 5 is equal to 11. And we're told that, right? And then we could be asked, what is the value of z? Well, here, all we have to use is use what we call inverse operations. And all that means is the opposite of what's happening right now. So we have to start with it. And the key with these, right, is PEMDAS, which is the order of operations. And it stands for parentheses, exponent, multiplication, division, addition, subtraction, where multiplication and division are the same importance as our addition and subtraction. But the key here is going to be that when we are actually solving these, we are reversing PEMDAS. Meaning whatever we would normally do last, we do first. So we start with addition and subtraction. That's why if we went to solve this guy up here, we would add 5 to both sides first. Add 5. Because what we do to one side of the equation, we must do to the other. And then we'd have 2z equals 16. And now we'd have to do the opposite of what's happening. So 2 times z right now is 2z. Divide both sides by 2. And you see that z equals 8. All right. And now those are fairly easy, right? Those are 1- and 2-step equations. The difference that we'll see with some of them, though, is that you'll have it with only variables, and we call those in terms of questions. And in those questions, one variable is isolated to start. And yet answer choices will have a different variable isolated. And you go, what do I mean? So you'll probably be given some long word problem, right, about this and that, some scenario, okay, right, some scientific scenario or some historical scenario. And it'll tell you, like, this is the equation for calculating the gravity on Neptune. And you'll be given this equation. L is equal to, 5NW over Z, right? And right now, what did we say? One variable is isolated to start. Right now, that isolated variable is that L, that fancy L that I drew, right? But then in the end, what if it said, give all other variables in terms of N? All that means, isolate N. Right now, L is alone. We want to get N alone. So we have to do exactly what we did over here, those inverse operations. Let's see what's happening first. Z is down there. Let's go ahead and Z is on the bottom of that fraction. Being on the bottom of the fraction means it's being divided. What's the opposite of that? What's the inverse of what's happening right now to that division? Multiply both sides by Z, right? So if we do that, we did that. Now we've got ZL is equal to 5NW. Still not quite where we want yet, right? We haven't given it in terms of N. We want N alone. Well, it's got 5NW around it. They're all being multiplied. So the way we get rid of them, divide by 5NW. That'll cancel it from this side. Divide by 5NW. And we've got now that 2L over 5W is equal to N. And that would be one of your answer choices. There you go. There's N in terms of all the other variables. Does that make sense? Ones like that ask us, that you start with one variable isolated, you look down at the 4 answer choices, and it's going to basically have picked one of the variables and have it isolated. The only problem is you'll have to know by algebra which one was isolated correctly using inverse operations. But those are very, very common. So I'll take a all right, that second one has been saved. And then we have one more thing to talk about for linear equations. Linear equation word problems. Still, our key is y equals mx plus b. That is our raft in the ocean that is linear equations. That's always our safety net, right? Getting something back to y equals mx plus b form, which fret not, right? All it really means is that y is isolated. Get y alone. And you're back in y equals mx plus b form. But for word problems, the x, y, M and B are going to have kind of special meanings. They're going to mean things in the context of word problems that are going to be important to us. And I'll show you what I mean. I'm going to give you two different scenarios, and I'll show you what I mean by each one. So first, let's start with y. Y is going to be the total, the end goal, as I like to call it. All right. And you'll see two different examples of this. I like to call it Girl Scouts and guitar bands. You'll see what I mean. All right. Next, X. X is usually the one that it's not going to give us a value for. X is going to be the thing we don't know. No value will be given. All right. M, the slope, is going to be what we call the rate of change. It's going to be how fast that X is changing. And it's going to be given away by words like per, for each, and for every. Those are going to be the giveaway words for that slope. You see that near a number in the word problem, and it's going to be the slope. Lastly, we've got B. That B is going to be our starting point, kind of where the Y value is when X is 0. And that's why we say it's the starting point. Or in some where you have somebody charging something like a price, it's going to be that sort of flat fee, whatever they charge to start before they even do a bit of work just to show up. What are they going to make, right? That flat fee. All right, so if we're talking Girl Scouts and we're asking, okay, these Girl Scouts, we're told that they are selling boxes of Girl Scout cookies, right? Each box costs $5. Let's see. Each box costs $5. And yeah, they're just going to try and sell as many as they can, right? So let's go through this. And they want to keep track of the total money that they make in the end, right? What's going to be the Y? Somebody put that in the chat. What's going to be the Y in this case? These Girl Scouts are selling these boxes of cookies for money. The Y is going to end up being it's going to be how much money is made, right? How much total money is made is going to be the Y. Yeah, exactly. How much they end up making. Very good. X is going to be the thing we don't know, the number of boxes they sell. M, the slope, the rate of change is that each box, right? It's that $5 per box. And then let's see, what would the B value be in this case? What's the starting fee? Is there a flat fee? Is there something that they're charging to begin with? Not really in this case, and there's not always going to be one. No, in this one it would be 0, right? There's really no flat fee for buying, these boxes. So this one would be kind of 0 in this one. All right, and that's going to happen sometimes. Now let's say a guitar band is at a record label, and the record label tells them, all right, guys, we're going to pay you. You're a pretty small band. You're not selling a lot of records. We're going to pay you $200 a month and $5 for every record you sell. Here, Y is the total money they get paid for a month, right? X is what we don't know. That's going to be how many records they sell. Somebody put what the slope is going to be. What's the slope and the y-intercept going to be? So in this case, the slope's going to be the $5 per record that they make or that they get paid. And then the B, the starting value, is that flat fee, right, is the $200 a month they get paid just for showing up, right, just for being a band. Even if they don't sell a single record, at least they're going to make $200. All right. So that is linear equation word problems. We're going to go ahead and stop the recording.